Hi everyone, welcome to our first machine learning meetup. It's quite a special time for our machine learning team. We are just two of two, but still, I feel like we have a lot of to share. Um, so, as Jirka mentioned, my name is Marek, and apparently, based on the meetup invitation, I'm senior software engineer. And when I saw the invitation, I was kind of confused because I don't feel like a software engineer. I mean, no offense to software engineers, but I feel like my kind of mission in Productboard is more like engineering the software or developing the software. So there is some things that are missing there. So I would just adjust the title a little bit. I would just adjust it to machine learning engineer or maybe data scientist. Nowadays, it's pretty hard to draw the line between what's the responsibility or maybe what are the skills of machine learning engineers or data scientists. I mean, I talk with business, I talk with product managers, I train the models. Hopefully, I produce the production ready code, but still, it's pretty hard to draw the line. So I will do a small adjustment here, which is I will just call myself as a machine learning guy. And yeah, I'm just doing whatever it takes to machine learning to happen at Productboard. So we have a lot of customers, they have different problems. So my kind of mission here is to utilize the data science or machine learning to help them. And this paradox or kind of confusion that I had myself actually leads me or brings me to the main topic of the talk, which is rise of MLOps. So I would like to talk a little bit what I think is what is MLOps, how it's helping us, where it's heading, and what should be the next trend as MLOps. Then I would like to share some more hands-on experience we have in Productboard. So as I mentioned, we are just a team of two, but we have a lot of unique problems, I guess. So I would like to just share our Pokédex of all the technologies and things that we are doing, and also mentioning the stuff that I feel like it's not working. And the last but not least, there will be quiz. So you should pay attention, I guess. But first, story time. So I'm not much good in painting, but I just paint my imaginary friend John. So let's just meet John. John is a predictive modeler. He just landed a job in an insurance company, which predictive modeling or predictive analytics is something like that some of you might not know. It's been like 10 years ago, and it's basically the data science or data science before it was cool. So training the models, etc. So John just landed his first job. He's happy about the job, and he started working with the business partners. So you have like insurance market, you have a lot of prediction problems, how to actually score your customers. And he just got the data from the data team. So in insurance company, like some times ago, it worked like you get the data prepared and you just work on the problem. So you work on the prediction problem, you just do some cleaning, feature engineering, you train different algorithms, you evaluate all the possible things that you can do to solve the prediction problem. And he's quite happy about his solutions. He actually hand over the solution to another team. So in insurance companies, at least 10 years ago, it worked like this. So you just hand over your coefficients or the model, and you are quite happy. So it's a great success, I would say. However, yeah, after some time, so in insurance companies, after let's say 1 year, you are just taking a look back at your models and trying to figure out whether they actually worked. So it's not like continuous evaluation of the models, but it's more like, okay, after a year we see what the market is like and whether the model actually scored their customers well. But yeah, someone just came to John and saying, yeah, your model sucks, or your model is doing some very strange things, and the portfolio or the insurance portfolio, all the customers, yeah, it's not doing very well. So John just deep dive into the predictions. He just did some retrospective and trying to figure out what was wrong with the model or what was wrong with the predictions. And after some deep dive, he found out that the team that took care of the implementation just made a mistake, right? Mistakes happen, and someone from the implementation team actually implemented some coefficient very differently. So John is confused. John actually really likes the job, but he's like, okay, I was working for some time on the model, and then there is no impact, or the model was wrongly or incorrectly implemented, so something is off, right? So after some time, John actually decided to took another challenge. He just moved to the another company. It was, let's say, startup, and he started as a data scientist. He was wondering whether outside the insurance or highly regulated field, whether there is a different data science, different predictive modeling, and so on. So he took a new challenge. He started in the company, and suddenly, he was confused, he was scared, but also he was excited because when he started, he has seen his colleagues to do the data science differently. Suddenly, there was things like Python, Git, and Docker, and so on. So suddenly, he found out that his even younger colleagues were doing the data science better. They were actually going far more rather than just training the model. They were trying to deploy the models and make a more impact. Yeah, and then life happens. John had to move to another startup, and yeah, it was a new adventure, new opportunity, because suddenly he had to actually create the machine learning team or found the machine learning team from the scratch, all the stack, all the problems, and so on. And John wasn't confused. It wasn't such a motion roller coaster that he had in the previous startup, because he actually learned to adapt. He learned to learn. He learned to how to work with the new technologies, how to actually leverage all the things around him to actually make an impact. So suddenly he was very excited because he actually can use any technology, any methods, any statistics or mathematics he knows or doesn't know, and use them in the new company. Now let's just say bye to John, and I would like to continue with or reflect on the John's experience and trying to connect it with the rise of MLOps. So if we talk about the MLOps, the question here is, are we talking about the tools, about the frameworks, about the programming languages? And yes and no, I think. There is a new course on the Coursera from Andrew. Andrew is one of the biggest personas in data science. And after the machine learning and deep learning courses, he just landed the new MLOps specialization course. And he's saying basically that machine learning is somehow overlapping or combining with the modern software development and engineering roles. So his motivation of doing such a new course is, I guess, is doing machine learning, but being as much good as possible to make it to the production and much more far. And if we just think about our last projects we had in data science or machine learning, I mean, in the beginning, you work with business people. You are trying to translate the business problem to data problem. Then you work on the problem, you clean the data, train the models, etc. But you ended up with the, let's say, POC or MVP, some kind of machine learning code that you think is ready and is solving the business problem. However, the reality is not so simple, because once you are done, there is a lot of things out there that actually you need to make sure that your model is performing and doing the thing that you have actually intended. And yeah, I would just summarize it. Just getting ML to the production is hard. Also, just keeping the machine learning in the production and behaving as it was designed is even harder. Um, Fortunately, even though it's not very easy to make machine learning to the production, there are things and there are tools and wrappers we can use. So I guess most of you know what this means and ever use it. So there are a lot of tools, wrappers that actually gives you the opportunity to not care about the very granular things, not to care about the statistician or mathematics and so on, and you can use them and then focus on the other things. As other things, I mean you can then understand the data more. You can try to understand the data. You can spend more time on the feature engineering. You can communicate with the people. So instead of writing the code from the scratch, like training the logistic regression or neural networks, you can focus on much more impactful things. And it's not just about the scikit-learn. There is a just universe, or I would say jungle or wild. There is so many things that you can use. I mean, like 20 or 30 years ago, I would say statisticians or mathematics that were doing the models before, they would be so happy to have something like this. So currently, we as a data scientist or machine learning people, we can actually version the data. We can label the data. We can run ETL at scale, even though we are not software engineers or infra guys. We can do so many things. On the other hand, we can utilize the already pre-trained deep learning models such as transformers. We can use TensorFlow. We can use Fast API and so on. So it's like I don't feel 20 or maybe 10 years ago I will be confident to writing the API that will serve my models. But now it's possible. And the question here is, we have a lot of tools, we have a lot of frameworks that are fortunately open sourced and they are done. No one needs to actually reinvent the wheel. But the question is this granted to any one of us? And I would say yes and no. On one hand, you can utilize whatever you want. You can do your own research. You can try new things. But there is a hypothesis, it's from biology. I really like this quote. And basically it's saying it takes all the running you can do to keep in the same place. And from the biology, it means that you have a lot of species in the nature. And those species actually need to adapt, learn, and actually change to survive, because there is so many things around that are already doing that. So they are changing and evolving. So just to keep the pace and keep the status between them, you should also run as fast as possible. And for me, this is kind of main message of the rise of MLOps. I don't feel like MLOps is something so cool because yeah, it's kind of new kid on the block. It's something new here. Everyone is hyped about that. But if I reflect like 5 or 10 years ago, there was a hype around data science, right? And maybe it's still here, I don't know. But it's changing, right? Once it's data science, then we have rise of MLOps, a lot of things you can now, as a data scientist, create API service. But no one knows what actually lies in the future, right? What's the next MLOps? What's the thing? Or what's the next thing? So for me, rise of MLOps or MLOps actually gives me the nice motivation to not just actually learning the MLOps, but learning whatever out there it is, right? So I would like to just adapt, learn, execute, and repeat. So that was kind of main message of the rise of MLOps. So it's, from my point of view, it's not about the tools, it's not about the frameworks, it's about our attitude and ability to learn new things. Because I feel like data science is one of the most progressing things out there. And if we just stick or keep in the past, then yeah, no one would now train the transformers or using the transformers for the business problems. The next section I would like to cover is giving you some more examples what we do in Productboard, because it's nice to talk very theoretically and philosophically about the MLOps, but I would like to give some sense how we are using such an attitude and the trends at Productboard. Yeah, I will just start very officially, which is what actually Productboard does. So I would call it just this is just copy pasted from our page. It's customer-centric product management platform, and so me as a data scientist or machine learning guy, I'm just trying to understand how our customers are using our product. So for me, Productboard is or should be the system of record for all the feedback on your product from your customers. So basically, you are trying to collect all the feedback from the customers and centralize it on one system of record. So this is the Productboard. So the first pillar or first foundation of the Productboard, from my point of view, is system of record. So all the feedback from very different sources are coming or flowing to the inbox or some system of record. Then you know what the customers are actually telling or thinking about your product, and then you can read the feedback. You can read the feedback, you can enhance or enrich the feedback by some data. You can prioritize feedback or actually score the feedback. So you see someone is very, very pissed about some feature you just recently released. So you can just score it as a critical or very important. So that's the foundation. Just you need to get all the data, pull all the data, all the feedback from your customers. And then once you got this kind of very grand work, then you can prioritize, right? So now you know what your customers like or not or don't like about your product. Now you can aggregate at the feature level. So basically, you know that your customers are complaining about a specific feature, and you know that it's critical, and maybe there is a risk of churn or something like that. Once you know what to build next, so basically if you know that your customers are actually not very happy about the specific feature, then you can build a roadmap, right? So you can just build the kind of communication rule to your developers, to your stakeholders, or to your execs, and also to your customers. So it's not just about the gathering or collecting all the feedback, but it's about the feedback loop, right? It's like, okay, I heard your opinion. I know that you are paying to us. I know that you don't like something. And on the other hand, you are trying to communicate, okay, I heard you, and I know that we should fix something or improve something. And the last piece is execute, which is the hardest part, right? And now I would like to just jump to the machine learning team. So as I mentioned, we are just a team of 2, but we are trying to actually make a lot of impact. So we have a lot of missions, a lot of things that we are trying to achieve at Productboard. The first one is trying to understand the customer. So I just mentioned the 3 pillars of the Productboard, which is like collecting, so system of record and prioritizing, and then the building the roadmap. And the machine learning team is currently focusing on the first part, because you can imagine that you can actually push a lot of feedback from various systems and sources to the Productboard. So the data is very unstructured. You can push any text, you can push any image, video, and so on. Some customer got more quality feedback, someone just pushing, very not good feedback, I would say. But we know that once the feedback actually lands in your inbox or in Productboard, then the job of the customer is actually process the feedback. So read the feedback, trying to figure out, okay, what the feedback is actually telling you, and trying to connect the dots. So connect the feedback with your features within your product. And there are too many manual steps that you as a product manager, as a user of Productboard should do to actually do this work to then prioritize. And we as a team are trying to actually mitigate the manual work. So basically, without even reading the feedback, we can suggest you or predict what should be the feature that actually the feedback is telling about. So we have a lot of multi-label, multi-class prediction problems. The another level of the mission that we are doing here or trying to understand the customers is, so let's say you are a customer that is receiving like thousands of feedback every day. So let's say thousands of emails or messages. And it's pretty impossible to actually read it all, right? It's like you are a human, you have a lot of things to do, and no one actually will actually read all the feedback and trying to figure out, okay, how I should connect the feedback with the features. So they're actually, they want some kind of abstraction on the feedback that is not humanly possible to read. So basically, cluster the feedback or give the feedback some sense at the scale. So you are a customer, tens of thousands feedback every day, and they would like to just see what are the patterns, what are the keywords, what are the topics or clusters that the feedback is about. Um, and the last piece of our mission is orienting the feedback efficiently. So even though you will set a time for processing the feedback, let's say in Productboard, product managers just keep 1 hour per week to actually process the feedback. 1 hour is not so much. You can process something like 10 or 20 messages because you can you read it all, and then you need to connect and figure out what's the link. But what about the thing that I can tell you as a machine learning team or some algorithms, what's actually worth your time? What's the high quality feedback you should read and process? And what's kind of junk that it's very repetitive, it's actually contains no valuable information to your business. So the last piece is more about the recommendations and sorting and measuring what's actually how to measure the quality of the feedback. And I just talk about the understanding the customers, so we know what are the things that our customers are trying to figure out in our application. And then once we got this, we can build a solution. So as ML engineers or data science team, we can then build the solution. So we are responsible for a lot of things. So now we talk the Pokemon or some technologies. We have a pretty standard data science stack, and we think about the data science as doing data science as a software engineer. So we are trying to keep all the best practices from our software engineering team because we have like hundreds of software engineers, and there is so much to learn from them. So we are trying to do things as good as possible. So our code or production code is not ending in the Jupyter notebook or SageMaker. It's just a place when we can experiment. Then we are rewriting all the code to the Python or any language you might actually prefer, and version all the code, and then package all the code to the Docker files and running as a Docker containers. And the last piece of our puzzle for building the things and running the things is Airflow. So some time ago, we have thinking what's the best orchestrator or where we actually can schedule our tasks, and we ended up with Airflow. Um, and once you build a solution, you know where you can run the experiments or production-ready tasks. Then you have also things like, I would like to run API or inference, and I would like to deploy my service. So it's not very useful to actually let the data science or machine learning team to deploy the stuff on Kubernetes. But what we do is we package our code, we create the applications, we use things such as Helm charts or Helm deployments, and we do the same things as our software engineers. So basically, we are running machine learning applications on the Kubernetes. At Productboard, we have event-driven architecture, which actually gives a lot of complexity to the things. But on the other hand, it's great thing. But we, as a machine learning team, are also incorporating the Kafka in our stack. So basically, everything what happens in Productboard application then flows in Kafka, and we as a team actually react to the messages and all the things that are happening in the application, and then scoring the events. So basically, if the new feedback actually flow to the application, then we can score it and provide the prediction back. And deploying stuff is great. I mean, you have a lot of out-of-the-box tools, but it's still like you should carry about the monitoring the afterlife, because we would like to not repeat the John's story, such as after 1 year we will find out that the model is actually behaving not very bad, not very good. So we at Productboard, we have a platform teams which are actually giving the tools and frameworks to our software engineers, and then they providing us a lot of tools such as Prometheus, Grafana, Datadog Sentry, and so on. And that's kind of great opportunity to the ML team as well to actually adapt such technologies. So we as a team have machine learning services which are scoring real-time the events in the application, but also we are then tracking all the health and what's happening in the application as a software engineers. So we know that our application is not just about the predictions, but we are caring about what's the response time, what are the number of requests, if the application is healthy, and so on. So we are bringing this software engineering best practices from our platform team to actually keep the service healthy and functioning. There is a question mark up there, which is next to the infinite loop or infinite sign. And you might ask, like, okay, we are doing these machine learning or the predictions as software engineers, but we don't care about the predictions and the quality of the model, which is not correct. Every prediction that is made is actually stored or logged in our database. So we have a lot of data about the training the models, about the reclassifying and creating a new predictions. And now currently we are working on the solution that will actually gives us the view not as a software engineers, but data science people. So we would like to know how our models are performing. Even though we have this information, it's pretty hard to visualize it on the top of the database. So we are trying to find the tool there. And yeah, there are things like model drift or concept drift or data drift that we would like to have visualized. So that's one piece that we are missing and working on. And I have promised the challenges. And those are, at least from my previous experience, those are very unique that I'm experiencing here. So Productboard got like thousands of customers. So you can imagine the customer is just a company, and company got like several users. And every customer got very different data. So you can imagine like Microsoft or Netflix, they have a lot of feedback. On the other hand, smaller companies, they have just a few dozens or maybe hundreds of the feedback. And we as a team, we see that it's pretty hard to actually come up with one solution or one model to actually train on the different data maturity spaces or customers. So we see that there are spaces which are getting very low volume of the data, and it's quite impossible to actually train the model on, let's say, 200 pieces of observations or something like that. Also, what's different is every customer is unique in terms of they are doing something else. Everyone got very own business, and they are treating their product board differently. So someone is very pedant, someone is just connecting all the dots, is doing a regular actually labeling the data, and someone just doesn't care. So also it's pretty hard to us come up with one solution and train the one architecture or come up with one black box model to actually train such a different volume of the data. So some customers might be suitable for neural networks. Some of them are suitable for basic some heuristics or something like that. Data quality is also quite an issue because you can push the feedback from various sources. So basically, there are hundreds of integrations, hundreds of sources, and every source is different. Some customers are pushing just very high quality feedback. So basically, they have like product manager interviews with their customers, and they have meeting notes, which are kind of distilled information, and they just push this to the product board, and it's pretty easy to the model to find the patterns and make the predictions and make the model, right, and predict the outcomes. On the other hand, we have customers that actually push everything from the Twitter or App Store and so on. And you can imagine those reviews or this feedback is not very high quality. I have mentioned the one solution doesn't rule them all. So basically, if we have like 6,000 customers or thousands of customers, and everyone is unique, no one got the same labels and same feedback, so the training data set is different, you can't train the one model, actually one general model. So basically what we are doing is we are training separate models per customer, which is actually a reason why we landed with the Airflow, so we can make all the runs concurrent and train a lot of models every day. Then I have mentioned the machine learning monitoring solution. So it's not just about the tools. I have mentioned the superset, or we can use Looker. It doesn't matter after all. What actually is our challenge is, so let's say you train, I don't know, 4,000 models every day, or retrain them. And now how would you aggregate the results? So you can, if you have one model, one internal model, then you can see what are the predictions, what are the mispredictions. You can do error analysis. You can do a lot of stuff. But once you have like 4,000 models, you need to somehow aggregate the thing, how the models are doing, was the data driven, was the model driven. So it's not very easy task. The next challenge we see within the team, even though we are just two, it's specialization versus full stack. So we are trying to actually, it's connected to the MLOps, and we are trying to actually do as much things as possible, which is great on the paper. On the other hand, I feel like a lot of people here would say it's not the ideal case, and we are thinking about when is the right time to actually specialize to one of the things in the data science lifecycle, right? So we can see that some of our members are enjoying the data science and talking to business more and doing some feature engineering, which is like awesome work. And some of us actually enjoy the Kubernetes and all crazy stuff there. So on one hand, we are just trying to do as much as possible, but we know that it's not sustainable for the long term, right? It's like, if you have like 5 or 10 people in the team, I can imagine you have one specialist which is actually giving the tools to other 9 people. And the last challenge we actually observed recently is data mesh and ML. So data mesh is also kind of MLOps thing. So there is a rise of data mesh nowadays. And what we see is that at Productboard, we have the event-driven architecture, which means you have decoupled services. Every service got own database, and it's kind of anti-pattern to share the database access. And that's something that's kind of clash of software engineering part of the Productboard and the machine learning team. And we are trying to figure out what would be the best actually communication, or what's the best interface between machine learning team as a consumer of any possible data at Productboard versus the kind of best practices and the decoupled services at Productboard. And yeah, that's our story, I would guess. Thank you very much. Okay, I would just go to the slide though. Okay. I can start with, let's say, 2 questions from Slido, and then whoever got question from the audience can just raise your hand. So what use cases are you solving with ML in Productboard? Okay, I think I have covered that, but I can summarize or repeat. So basically, Productboard as a system of record for any feedback. It's the feedback is very unstructured, so you have a lot of text, a lot of different information, and it's very time consuming and a lot of manual work to actually get from the stage one, which is the collecting and processing, to the stage two, which is prioritizing. You can't basically prioritize or properly prioritize the feedback if you don't connect the dots. So basically what we are doing is predicting the links between the feedback. So you can imagine like raw content of the feedback with the features in your product hierarchy. So basically every product board customers got own product hierarchy, which is representing your product with all your features. And some of the feedback is actually addressing your one feature. Another feedback is complaining about the other feature. So we as a team are suggesting the links between the feedback and the features. Yeah, I have mentioned the another ones, which is like clustering. So yeah, we are doing the clustering, or we are researching the clustering with the transformers, and we are trying to actually give this summarization of the feedback without even looking into the feedback. So if you receive like thousands and thousands of nodes per day or week, we would like to give you the overview. Okay, this is behind the feedback, and this is the cluster, or this is the team, or this is what feedback is mentioning. Okay. Can you give us a taste of what ML tasks you deal with at Productboard? Okay, someone was not very patient. Next one. Yeah, I just mentioned the use cases. Do you have a data annotation team? Where do you get your data from? Social network feedback forms. Yeah, we just work with the data that our customers are keeping in the Productboard. So we don't annotate because you as a product manager actually creates such a link. So you can go to the feedback, you will read the feedback and connect the specific part or the whole feedback to respective features. So from the ML perspective, customers are doing the labeling, and then we are trying to train the models based on that data. But as I mentioned, sometimes it's not so simple. Sometimes customers don't care about the links, and that's another challenge. Okay, any question from the audience? No question. Okay. Where do you see ML in 5 years' time? Okay, that's a tricky one. I was thinking about the presentation that MLOps is just a trend, and I was asking myself what's the next trend. But yeah, I don't know. I feel like there is a rise of auto ML, but I don't feel it's so successful, because after all you can run the auto ML frameworks, but you need to do a lot of things around. So basically cleaning the data, who will actually label the data, right? So auto ML I feel like there are a lot of startups that are trying to go this way, but I don't feel like it will steal our jobs or anything, because there are so many other things that you need to do to actually run the AutoML. So I don't know. I feel like maybe some auto cleaning data or auto labeling is already here. I don't know. Something about the cleaning the data. Someone will just find out that it's not about the models, it's about the quality of the data and how you treat the data. So maybe there will be some new trend around that. Next one. How do you outline utility function for the feedback quality? Oh gosh, what's that? How do you outline function for the quality? I don't understand the question. How do you outline utility function for the feedback? Okay. Yeah. So how I will translate it. How we would actually measure the quality, something like that. Um, So we got this research, and we just interviewed all our or some our product managers at Productboard, and we have tried to find what are the hypotheses or the features of quality feedback. So on one hand, you can measure the so basically you have things like TF-IDF, so basically the NLP methods on the top of the text that actually filter you out the text features. So that's the kind of our approach. So you can somehow say if there are words that actually have meaning if compared to other documents. The another approach or the next approach could be just asking product managers. That's what we have done. And they said us that it depends on the source and the customer. So they have seen that some sources that are actually coming to the product board, they tend to be in a higher quality. So if someone sends you the email, someone just send email, make some work, actually care about the content. So maybe that's just a source as a feature could be higher than I don't know, App Store or something like that. So we have two approaches. One is like ML-ish approach, so somehow measure the quality and information in the text, or compared to some dictionaries or so on. And other thing is just collecting the features from users. So basically what they think is the best one. Someone just said that if the feedback mentions our CEO, that's kind of important feedback. So it depends. How long it takes to deploy model to production at Productboard? Yeah, the first model, it took like half of the year, but it also, yeah, I mean, training the model or coming up with the model and the machine learning code is the easy part. But we struggled a lot with orchestrator. So basically, where we can run such a jobs. So we spend more time actually with Airflow than with the data science itself, which is kind of crazy. What's the ML stack at Productboard? Yeah, there was Pokédex, so I guess I answered that. How do you deploy a model without understanding its inner workings? Its inner workings. So yeah, on one hand, so if you have like thousands of models, you don't know actually what's behind the model, what are the features that actually the model or the cleaning pipeline has picked up. Understanding its inner workings. I mean, we don't deploy like models that we don't understand what they are doing. We have a lot of so for the sparse spaces, so the customers that have very little data, we're actually not training the models. We are doing some kind of heuristics or similarity approaches. So basically, we are trying to comparing the documents and figuring out what could be the label, because training the model on 100 or 200 observations is like, it's not very feasible. Next one, couldn't you gamify product board, like label data properly, and we will give you great automatic insights? Yeah, I mean, they are doing that, even though they don't know that they are doing that. So basically, if they do their regular jobs, so every day they will come to the, because Productboard is not just about the system of record, it's about giving their best practices. And one of the best practices of product management is also reading the feedback from the customers, right? So we are actually trying to we are trying to get them to read the feedback and label the feedback. Sometimes we got feedback from them that predictions are off, which is fair. It's like if you have thousands of customers, some model will be off. And we are just saying that, okay, it's off because you are not labeling much. So just trying to cheer them to label more. And once they do such a work, the model will get better, basically. Okay, there are a lot of questions. What was your ML team's biggest fail since you started to implement ML into production? Yeah, biggest fail. Yeah, it was, I mean, yeah, we just shut down the whole Productboard application once. Yeah, the thing was that if you run like thousands of tasks, so in Airflow, every customer is separated in on Kubernetes pod, which gives us actually data separation. We can't actually mix the data for the customers from the security perspective. So what we are doing is like if you have like 5,000 customers, you have like 5,000 containers. So you don't do like within one container or machine, you don't loop the customers. And we have done this for a first time, and we found out that we are running our Kubernetes workloads on the cluster, on the Kubernetes cluster that is dedicated to our application. So basically, somehow we run like 50 jobs concurrent, and it was squeezing the resources of the cluster of the Kubernetes node. And yeah, suddenly there was a not very good meeting with our infra guys. And yeah, it was my last day of the vacation, so it wasn't very happy day. Um, what was okay? Is the PPT and Productboard template, or you did it yourself? Oh, okay. It's called Pitchcom. I mean, we have a regular hackathons, and last hackathon, someone from other team came up with the application which is called Pitch.com, and it looks great. So I would recommend that. You said that you need to retrain the models every day. Have you experimented how fast the performance degrades? Yeah, I would say this is the biggest challenge we have. The thing is that every day there is a new feedback, and if product managers are doing their job, there are new labels as well. So basically, if the feedback comes to the system and they come to the product board and they connect the dot, that's kind of connecting the observation with the label. So basically, we need to reflect that. Also, what's tricky is that every day you could have a new label because someone just say, okay, we have a new feature or we have a new sub-feature. So the data structure and data is changing every day. So yeah, we need to retrain that. And what we are tracking actually is how many predictions are changing. So basically, for each piece of feedback, you have the prediction, what are the outcomes you would predict. And every day we are comparing the previous day and today's predictions, so we know what's the drift between the predictions. So we know that some customers, if the new model is trained, the predictions are sometimes changing a lot, sometimes not. Do you use Productboard for Productboard development management? Yes. Yeah, we are using Productboard. Yeah, within the team, we are using Productboard as a backlog for machine learning team. So anytime we have idea, we just store it to the Productboard, then prioritize, and then push to Jira and work within the Kanban as a ML team. Reading the, I mean, are those questions ending or? I mean, I can talk, but it's like we have another awesome speaker. Okay, what are the important metrics that we are trying to improve in production? So I don't know, but recently what we have actually faced was the inference throughput. So basically you have a real-time service which is scoring real-time the new feedback, and sometimes customer is importing the feedback in bulk. So you can have like thousands or even more feedback like imported to the product board, and our service is trying to score all of those. And we have seen that our service, quite a struggle with it, but we identified the technical depth. We knew what we were doing wrong. So we were just improved the throughput like 10 times or something like that. And it was like worth like 30 minutes of our work. How many languages PB support? I mean, the UI, I don't know. The feedback you can push to the product board, it's like there are no limits, I guess. Do you deal with explainability in your models? So given all the projects we have, those are not very invasive. So basically what we are doing is for each feedback, we can give you the suggestion. So basically we are showing you the prediction, but not forcing you to actually use this prediction. So that's kind of less invasive method. And if you are a product manager and you like the prediction, you can just click and link the feedback very quickly. On the other hand, we would like to actually use these predictions to make the links automatically. And then I would guess there will be questions around why actually you link this feedback with this feature. And then we will need to actually explain why the model decided in that way. But we are not there yet. Yeah, last one. Do you deal with... Okay. Do you deal with explainability? Ah, okay, that was what I have just answered. Okay, thank you very much, guys. Cheers.